Alright guys, let's perform a relay attack when signing isn't enforced. This way we can redirect our credentials to another host and gain access. Alright, let's begin. We have a host here. Let's check the host name. SRV01. Well, let's run ipconfig. It has an IP address 10.10.10.20. Now let's check its settings. The first settings we want to see are the server settings. If this host acts as a server when others connect to it and when it shares resources. In the server configuration, it's false, meaning it doesn't enforce signing. It's just not enabled. Now let's see how it looks when it acts as a client, so when it connects to someone else. So as SMB client configuration, it has the same settings, and we see that as a client, it can use signing, but there is no enforcement. All right, let's check another host now. Host name, Windows 11, ipconfig shows 10.10.10.40, and again, let's see how it looks. If it acts as a host, sharing resources when someone connects to it, do we need a signature when connecting? No, it's not required, and there is no support. So also, let's check what happens if we act as a client from Windows 11, wanting to connect somewhere. And at this point, we can connect with SMB signing, but we don't have to. Now let's check how this looks from Kali Linux. Well, first we will scan the address 10.10.10.20, which is this host SRV01. And there we see message signing enabled but not required. And likewise, if we scan the address 10.10.10.40, it's also enabled but not required. This is strange because when we looked at the settings for the server configuration, the enabled setting was false. And the same for Windows 11. The server is marked as false. However, with Nmap, there can be a slight difference because it checks what protocol version it is and if the version supports it. So it says it's supported but not required. That is the difference. Nmap may interpret it slightly differently. Okay, now let's go to Kali Linux. And here we can search for servers that don't support SMB signing. Of course, we can use Nmap, but also we have other tools like netexec and so on. So we can run the command sudo apt and install netexec. And we see it's already installed. Now, using netexec, we can tell it to scan the entire local network and see if there are any hosts that don't enforce signing. And what do we see? Server DC01 enforces it. But SRV01, Windows 10, and Windows 11 don't enforce it. Additionally, we save this to file tmp_relay.txt, so we can check that tmp_relay.txt and see those three hosts: 10.10.10.20, 10.10.10.30, and 10.10.10.40. These are the hosts that don't enforce signing. Now, if we can intercept the NTLM authentication, we can relay to one of these hosts. These hosts that don't enforce signing, they don't check the signature. And now, to perform a relay, we need to get access to the data. We can use various techniques. One of them is, if NetBIOS is being used, sending a message that we are the host, especially when someone makes a typo in the name. So what do we need? We need responder, of course. Responder will respond, hey, that's me, I'm the host. And first thing is responder, we need to configure it properly. So we configure etc responder, responder.conf, and here we see NetBIOS and LLMNR were enabled, and so on. Yeah, so now if someone uses a NetBIOS name, for example, /server/something, and happens to make a typo, we will say, hey, that's me. So by default, responder listens on various protocols, also listens on SMB and others, and now we want to use a relay tool. So respondle itself doesn't do relay, so we need to make sure we are not using responders SMB, meaning we need to set it to off and also set HTTP to off. We disable it so it doesn't set up a fake server on those ports. Why? Because we need those ports for another tool. We will simply use a different tool specifically for relay. We save these settings and we have responder, and now we can create two windows. In the top window, we have responder. We can launch it in verbose mode on interface ETH0. So we have responder running, and now when someone asks, where is this host via NetBIOS, it will send a signal, that's me. This means other hosts will want to connect to Kali, so we now need to handle this connection and redirect to others. For this purpose, we use in-packet NTLM Relay X. So we will use another tool, in-packet NTLM Relay X, and with this tool, we will do the redirecting. In-packet will listen on the SMB port, and when someone connects to us, thinking they are connecting to the proper host, we will intercept that connection and relay to the host on the list, TMP relay TXT. Interactive mode -I means we can connect to this session. Okay, we start NTLM relay, and now let's say we go to Windows 11. On Windows 11, we open File Explorer and try to access the computer. For example, server 1. But let's assume we made a mistake in the name, and instead of server, we typed server. And of course, it doesn't exist. That name is simply not there. But let's go back and see what happens. The moment we use that backslash, that was enough for Windows to start searching, and now Windows started scanning our local network. We are asking, is there a computer with this name, and so on, and we can now see that we intercepted the connection and tried to authenticate to hosts 10.10.20, 10.10.30, and 10.10.40, and it succeeded. And now that we have authenticated here on Kali as the attacker, you can see that I don't know the password at all. The only thing I did was place responder and relay. So at this point, we intercepted someone else's credentials and forwarded them to the vulnerable machine that doesn't check signatures. The machine should check SMB and verify whether the person connecting is legitimate. Because at this point, as Kali, we intercepted this data and we're connecting there with the data we intercepted from that Windows client. Okay, and well, now what do we have? On port 11,000 on localhost, there's an SMB client shell setup, but there's a shell we can use for that SMB service that connects to 10.10.10.20. So now we'll open a new window, and using netcode, we can connect to 127.0.1 on the port 11,000. And here we've got the SMB client shell that establishes a session with the vulnerable host 10.10.10.20. Now we can put on the info command and get information about who we are relayed to. At this point, this connection on port 11,000 goes to server SRV01, and we can see some information. For example, information like shares. What shares are visible here? Yeah, so we can see admin dollar, C dollar, and so on. So C dollar, of course, it's a partition, so we can use this share. It might contain some, as we know, interesting data. And at this point, once we've used this share, let's say we want to use it by typing use C dollar, and we can then use ls to display what's there. So I can see there are many different files, so practically I already have access to the file system on this server without a password, without anything. Now it would be good to see if I have any permissions there, because we can probably read, but let's see if actually I can do even more, like create something malicious. Let's see by typing mkdir attack, and if we can create a directory. Well, we type ls again, and it worked. we have the attack directory. Okay, since we managed to create the directory, maybe we will write something in it. Yeah, so we're gonna split the window and type echo attack successful for the proof, and let's create a file tmp-info.txt. All right, we get the file. So now we can upload this file to the server, so we can go to the attack directory. And we run command put tmp-info.txt. And at this point, what we can do is ls and see that the info.txt file appeared in this directory. And now if we go to server 01 and enter the file system, we will see that on drive C, the attack directory appeared and it has the info.txt file with attack successful written inside. So we can see that the attack succeeded and we were able to relay to the server and create something on that server. So once we are on that server, we can type that NetUser command to see what users we got. And we got 4 users: administrator, default account, guest, and WDI G-utility account. Now we can return to our attack on Secure Kali to our main window. Here we can stop this attack and we will modify it a bit, because now instead of loading hosts from a file, we have a regular target that we're going to provide manually. I already know that 10.10.10.20 is vulnerable, so we can tell it attack this host 10.10.10.20. This time, we don't need the interactive client shell. Instead, I'm going to give it a command, for example, to create a user attacker. We see that there is no attacker user there now, but we're telling it, instead of creating an interactive shell, execute the command NetUser attacker password 123 and then add. At this point, when I run such a command, let's say I'm on the Windows client again and I make some typo or create a shortcut pointing to a non-existent name, and someone enters that share and clicks this shortcut. And what do we have? Well, we see that some command was executed. There was successful authentication on 10.10.10.20. What's more, the command was executed, so the command was completed successfully. So let's go to SRV01 again and check that same command NetUser once more. We see that now we've got the added user attacker, so we succeeded. At this point, if we have a relay attack, we can also execute various commands. We can pass commands to execute. We can also try to go further, so let's stop this attack again. We can open another window, and now let's create a reverse shell. In ifconfig, let's check my IP. It shows 10.10.10.106. So I'll create on my IP a file, tmp-r.exe, using, for example, msfvenom with payload Windows x64 shell reverse TCP. And I'm gonna listen on the lhost 10.10.10.106 on Kali port 4444. And at this point, the file is created, saved in tmp-r.exe. So what do I do on my side now? Since the file is a reverse shell that should connect to Kali on port 4444, I need to listen on that port. So I start NC, so the netcat LMVP 4444, and I get the message listening on any 4444. Yeah? So this netcat will be listening here, but now I need to deliver this malicious payload to the target. And at this point, I go to the first window and modify. This time, we won't use a command, but I'll give the parameter SMB to support -e and point to tmp-r.exe. And because I want the r.exe file to be uploaded to the machine, I'll rely to and execute there on that machine. I launch this, and if I catch some traffic, someone trying to connect to me, for example, I do the relay, and together with that relay, I'll transfer r.exe there and execute the file. And we go to our Windows 11. we try to access a non-existent server. Here we look, there's already a relay, and we see information uploading file. So let's go to the other console, and in this console where netcat was listening, we already have a connection from that host, and now we can check the host name. And we see it's server 1, and the ipconfig shows 10.10.10.20. So we have access to this shell. This way, if SMB signing isn't enforced, guys, we were able to relay the connection. As you can see, we don't need any passwords. We simply look for machines that do not enforce SMB signing, and then we have several attack possibilities. All right, guys, that's it. Thank you so much for watching. Make sure that you're gonna subscribe to our channels and follow CQURE and CQURE Academy in social media. As always, we try to do our best to deliver the best content to you and the most practical content to you. So hopefully you enjoy the video. And as always, stay secure.